All right, so today this is for the video for the Pythagorean Theorem Application review. So go ahead and turn to number 9 on that packet. Now this one, let's go ahead and look at number 1. It says, use the Pythagorean theorem to find the distance between points J and K, write the theorem, and show the substitution and all work. Now, we have 4 points on this graph, but they want us to only look at points J and K. And they want us to find the distance. So I'm going to go ahead and find J and draw my line from J to K, okay? Now, once again, we have our distance, our 2 points, and we're going to use the Pythagorean theorem in order to find what that distance is. Okay, so I have my Pythagorean theorem, which is a squared plus b squared is equal to c squared. And in order for me to find the distance, I'm going to have to draw my 2 legs on both sides. Okay. Now, I'm going to go through the process of counting how much each leg has for a unit. So looking at leg A, I have 3 units because I'm counting the boxes. I have 1, 2, 3, okay? And then looking at leg B, I'm once again doing the same thing. I'm counting the units between K and the other point. I have 1 unit, 2, 3, 4, 5, and 6. So that means that leg B has 6 units, okay? Now that I have my 2 legs, I'm going to go ahead and substitute that into my theorem, which is A is 3, which is 3 squared, plus 6 squared is equal to c squared, okay? Because we're trying to find out what my hypotenuse is, which is the same thing as my distance between J and K. Okay, so go ahead and start simplifying your exponents, which 3 squared is equal to 9, 3 times 3, and then 6 squared is going to equal 36. Okay, I still have to add 9 plus 36, which is going to equal 45, is equal to c squared. And I still do not have c by itself, so I'm going to square root so I can get rid of that exponent of 2, which is squared. And whatever you do to one side of the equal sign, you also have to do to the other side. So the square root of 45 is going to be 6.7 units. So C is equal to 6.7 units. Now, make sure you are reading through all of the directions. If it doesn't tell you, you'll just round to the nearest tenth. But go ahead and round to the nearest hundredth if the directions tell you. But other than that, just round to the nearest tenths. All right, looking at number 2. So this one says Tina measures the distance between 3 cities on a map. The distance between the 3 cities are 45 miles, 56 miles, and 72 miles. Do the positions of the 3 cities form a right triangle? Write the theorem and show the substitution and all work. Explain your reasoning using mathematics vocabulary in complete sentences. Now remember, when we are trying to see if something's a right triangle, we're using the Pythagorean theorem again, but we want to make sure that our 2 legs equal to be the same thing as our hypotenuse. So what I'm going to do is I'm going to write my theorem. I have a squared plus b squared is equal to c squared. Okay, and I'm going to plug in my measurements into this theorem. Now I have 45, 56, and 72. The only thing that matters that you have to plug in correctly is the biggest number. Remember, the biggest number is always going to be your hypotenuse, and the biggest number out of those 3 is 72. So I'm going to go ahead and plug in 72 squared for C, okay? And that leaves me with 45 and 56. Doesn't matter which one you pick to be A or B, as long as you plug them in for the legs, because they're the smaller numbers out of the 72. So I have 45 squared plus 56 squared, okay? Now I gotta go ahead and start simplifying. So I have 45 squared is 2,025 plus 56 squared is 3,136 is equal to 72 squared, sorry, is going to equal 5,184. Okay, I have to simplify what's on the same side of that equal sign, which is just adding my 2025 plus 3,136, which is equal to 5,161. Okay, now there's nothing that I can simplify on the right side of that equal sign, so I'm just going to bring that down, which is 5,184. Now, if you look at both sides, they do not equal out to each other. Okay, my two legs do not equal the same thing as 5,184, which is my hypotenuse. Therefore, I do not have a right triangle. Okay, now I have to still explain my reasoning, and I have to use my vocabulary. Okay, we know that we have legs, we have hypotenuse, we have the Pythagorean theorem. Okay, those are the few vocabulary words that we have for this unit. Okay, so what I'm going to do is I'm going to write, we do not have a right triangle because using the Pythagorean theorem my two legs do not equal to the hypotenuse. Okay, there are different ways you can describe or explain this as well. You just want to make sure you are using your complete sentences and also using the vocabulary. Okay. All right, moving on to number 3. So this one, it says a triangle has a leg that measures 24 centimeters and a hypotenuse of 25 centimeters. Find the length of the other leg. Round your answer to the nearest tenth, so there it tells you what to round to, if necessary, and write the theorem and show the substitution in all work. Correctly label your answer. Okay, so they want us to write our theorem, and remember, anytime you are using the Pythagorean theorem, you have to write down that theorem. They want you to show substitution in all work and correctly label your answer. Okay, so you want to make sure you label your answer at the very end. Okay, now my theorem is a squared plus b squared is equal to c squared. Okay, and they give us two measurements, which it says one leg is 24 centimeters and our hypotenuse is 25 centimeters. Okay, so that means I'm going to either plug in for a and b, or a or b, and then plug in for c. Okay, so I can use 24 as a, so I have 24 squared because it's a leg. And I'm going to go ahead and just leave b squared because I don't have a measurement for my second leg. So I'm going to solve for b. And then my hypotenuse, which is always represented by c, is going to be 25 squared. Okay. Go ahead and simplify. I have 24 squared is going to be 576 plus b squared. Once again, we can't do anything with that. And then 25 squared is equal to 625. Okay, now if I have to solve for b, if I look at my two measurements that I just simplified, they're on opposite sides of the equal sign. So I have to combine them by moving one of them to the other side. If I'm solving for b, I'm going to want to get that by itself. So I'm actually going to subtract the 576. Okay, that cancels out, leaving me with just b squared is equal to, and when I subtract 625 minus 576, that is going to equal 49. Now the reason that I subtracted, remember, anytime I'm moving something to the opposite side of the equal sign, I'm using the opposite sign. That 576 was originally a positive number, so that's why I subtracted. Okay, now b, I'm solving for b for the other leg. B is still not by itself, so I have to square root b on both sides. That square root and the square cancel out, leaving me with just b, and the square root of 49 is equal to 7. Okay, now that is not my final answer still, because it's still telling me to correctly label your answer, which we are in centimeters. So my final answer is my other leg is 7 centimeters. All right, moving on to question number 4. So question number 4 says, Monica needs to walk from her dorm room in Wilson Hall to her math class in Wells Hall. She usually walks 500 meters east and 600 meters north along the sidewalks, but today she is running late. She decides to take a shortcut through the tundra. Okay, so if I look at this image that they're giving to us, right here, moving east, I'm moving 500 meters, and then moving north, I'm moving 600 meters, okay? Now, the first question is asking us to find the distance of the shortcut, which our shortcut is from Wilson Hall, which is right here, to Wells Halls, which is right here, okay? That means we are finding our hypotenuse. So I'm going to write my theorem, which is a squared plus b squared is equal to c squared, okay? And now I have to use my substitution using the measurements that they gave me, the distance, okay? So they give me my 2 legs, doesn't matter where you plug them in as long as you're consistent. I'm going to go ahead and plug in one of my legs, which is 500 into A, so 500 squared, plus my other leg, which is 600 squared is equal to c squared. I go ahead and simplify. 500 squared is going to give me 250,000 plus 600 squared is going to give me 360,000 is equal to c squared. Okay, I still can simplify one more by adding those two numbers, which is going to be 610,000 is equal to c squared. Okay, so 250,000 plus 360,000 is going to equal 610,000. Now, c is still not by itself, so I still have not figured out what my distance is. So I have to square root on both sides because I have a square on c. The square root and the square cancel out, leaving me with just c on that side. And the square root of 610,000 is going to be 781 meters, okay? And that is with me rounding to my nearest tenth. So 781 meters. Now, example B says, how much shorter is a shortcut than Monica's usual routine, okay? They're asking us how much shorter something is. They're trying to find out what the distance is because they want me to figure out how much shorter something is, okay, the difference, okay? So I have to show my work and correctly label your answer. Now, I know that the shortcut is 781 meters, okay? And when we're using difference, when we're trying to find out how much difference something is, we're using subtraction for our, I'm blanking out. Why am I blanking out? I am using subtraction as my problem, okay? So the only thing is that I don't know what to subtract to because they want me to, I have 781 as my shortcut, but what I'm trying to find the difference of is Monica's usual route, okay? And at the very top, it tells me that her usual route is she walks 500 meters east and then she walks 600 meters north, okay? If I add those two distances to each other, because that is her normal route, I get 1,100, okay? And I'm actually going to subtract those two distances in order to figure out how much shorter one is to the other, okay? Now, 1,100 minus 781 is equal to 319 meters. So that is how much shorter her distance is going to be from her normal route. Okay. All right. And the very last question, which is, which equation could be used to find the length of the slide? So the length of the slide is right here, which is once again represented by our hypotenuse. And when we are using the Pythagorean theorem, we have a squared plus b squared is equal to c squared. Now, when we're using that, we don't usually see any square roots, and we can't really use the square root to cancel out, because if we were to cancel out the square root, they would both cancel out, meaning there would be no square root in our equation. So that means that we can go ahead and cancel out a and c, because we're not going to see a square root in our equation when we're trying to find out that length, okay? That leaves us only with b and d, okay? Now I have 10 squared plus b squared is equal to 19 squared for b. And then for d, I have 10 squared plus 19 squared is equal to c squared. Okay, now if we're trying to find out our hypotenuse, remember that's always represented by c. Okay, so we don't have a measurement for c, but we have measurements for both of those legs, meaning we are going to fill in a and b to figure out what c is going to equal. Okay, for b, option b, we still have b as if we were supposed to solve for it, meaning we're solving for a leg, but once again, we have both of those measurements, so that leaves us with d. Okay, 10 squared plus 19 squared is equal to c squared because we're trying to figure out what c is equal to. Okay, all right, make sure you are asking questions, joining those office hours. Make sure you email me if you have any other questions, and make sure you submit all of your assignments. Okay, see you guys later.